To begin understanding how blockchains function, we should first be aware of what they do in the most generic sense. We describe the data in the blockchain as a ledger, which is a good name. Another descriptive word for blockchain data is a register. The data is a list of events that have happened, a chronology, if you will. In cryptocurrency blockchains, these events are brief descriptions of monetary transactions. Alice paid Bill, Charlie paid Dolores, Bill paid Charlie, and etc. These events can also contain simple data chunks, like messages, documents, images, or whatever. The event data can be stored within a blockchain as a unit called a transaction, and not only represent a monetary exchange, as in cryptocurrency, but also just a nondescript event that places that data into the blockchain for safekeeping. We understand now what makes up the content of a blockchain transaction. Let's talk more about how these transactions are recorded in the blockchain ledger. We know that a blockchain network is composed of a number of nodes. Each of the active nodes in the network do much of the same as one another in that they all listen for new transactions to be introduced to the network. Say when Alice pays Bob, or Edward stores a selfie. Specific network protocol announces each new transaction to all active nodes of the network. Each node has its own copy of the ledger, and when a new transaction is announced, each node records the details of the transaction event in its ledger copy. The net effect is that every network node contains a redundant copy of the network's transaction history. This feature yields massively distributed data redundancy, if nothing else. This ledger, with all of the blockchain event history, would over time become a list miles and miles long with millions of individual transactions. Having so many individual entries can become unmanageable and even clunky. Many blockchain implementations break this list down into more manageable units. Transactions are grouped into smaller chunks called blocks. The number of transactions in a block depends on the specific blockchain, but we can think of a block as a small number of transactions from the overall ledger list. So, instead of simply individual transactions, the ledger is actually composed of blocks, which each contain transactions. These blocks are then linked together in a very specific way, one referencing the next, and the net effect is the chain of blocks we discussed earlier, or simply the blockchain. With that, let's now talk a bit about the network itself. Who are the participants in the blockchain network, and why do they choose to work together? If we go back to the bank example presented in the first video of this course, we identified the issues in placing trust in a third party to maintain a ledger of our monetary transactions. We discussed how risky it is to have a third party do this for us when it would be better to do it ourselves. And we know blockchain technology has come to help us do it ourselves. Not only that, but blockchain's decentralized distributed architecture that enables massive data redundancy provides a much more secure venue for our transactional history than a bank or any other centralized third party could ever provide. This venue is designed to benefit the stakeholders versus a third party which is organized to benefit itself. The participants in a blockchain network are not people, they're nodes, which are computers. The activities of these computers is orchestrated by software that each node runs, and the behavior of each node is then controlled by the protocol that the software dictates. The overall effect is that all network activity is predictable, controlled, and secure. The people who introduce nodes to the network do not have to know each other in any way. They only need to bring the node up on the system and be sure the computer is connected to the network. This is in high contrast to how trusted third parties operate, where anonymity is scarce. So, to get back to the original question of how do blockchains work, we've seen that blockchain data is essentially a ledger or register of events that have happened on the blockchain network. We learned that this list of events is broken down into blocks that contain a portion of these events. We discussed how the blockchain network itself is composed of nodes, which are computers running software designed to support the network's protocol, and how all of these things together eliminate the need for a centralized third-party authority to keep track of events when a trustless organization like the blockchain can manage them much more effectively.